Hello and welcome. Today I'll be talking about kindergarten through 12th grade cybersecurity standards proposed by New York State's Education Department. To start off, I'd like to give a brief introduction. My name is John Martin and I graduated from Onondaga Community College with two associate's degrees. One degree in computer information systems and the other one in business administration and management. I am currently a student at SUNY Canton, enrolled in their bachelor's degree program for cybersecurity. I have also studied cybersecurity and ethical hacking for approximately the past 3 years. I am currently a network administrator for a nonprofit organization located here in Syracuse, New York. To start off, I would like to talk about the strengths associated with the proposed K through 12 cybersecurity standards. These that you see on your screen are guidelining principles that they adhere by: equality and access, interdisciplinary actions, coherence, relevance, and engagement. The way that New York State Education Department has set this up is to divide them into different groups by their grade. So to start off, we'll be diving in kindergarten and first grade. These are the main concepts that they propose initially: impacts of computing, computational thinking, network and system design, cybersecurity, and digital literacy. With that being said, I am not going to go over all the information provided on this screen, but I will be touching on a few key topics. So, initially, as you see here with society, they want to identify and discuss how tasks are accomplished with and without technology, which does get students thinking a little bit more in depth about their day-to-day life with technology. I like how they start bringing ethics early on in this. It's never too early to learn about ethics in and outside of the classroom. They want you to identify computing technologies in the classroom, home, and your community. This gives them the ability to know exactly what they're talking about, whether it be hardware or software. Accessibility: make sure a teacher's there with all the computing devices that is necessary to take an in-depth look at this very young age. And last but not least, career paths, which career paths I believe should be much later in your education compared to kindergarten. Now, as we move down, we go into computer thinking, modeling and simulation. Identify and describe one or more patterns found in nature or design and examine these patterns to find similarities and make predictions. That is great. One thing that I have learned in my years of studying cybersecurity, IT, and now having a job in the IT world, one of the biggest things employers look for is your problem solving skills. So it's always good to make sure that students know basics about problem solving skills as soon as they get into the workforce. Now, again, I'm not going to go over all this, but here are a few of the dynamic features of this. Now let's move on to networks and systems. Identify, as you see, hardware and software. Identify ways people provide inputs and get outputs from computing devices. This is the start of letting them know basic networking systems and how they interact with one another, which is needed in most of these instances. Cybersecurity: identify reasons for keeping information private, which is amazing to bring that up with initially with the younger students, because everybody knows we do not want our credit cards, social security number, birthdays, etc. leaked out on the internet just to safeguard yourself. And those are some of the possible risks they would talk about. We also have talk about safeguards and responses to those safeguards. Again, the clarification is right here on your right. Next, we'll talk about digital literacy. As you see, digital use is one of the main components presented right there. Identify and explore keys on a keyboard, which I believe would be typing classes or learning more about what has gotten us this far with keyboards and mouse. And as you see, digital citizenship right there. Identify actions to promote good digital citizenship and those that do not. I feel like this is more classified under the category, please do not cyberbully people. I mean, act like they're there and be respectful. That's really the matter on that. Now, we're going to move in on the next part of it. This is basically just reassuring what all we just went over. And these printouts will be available after. Next, we'll move into second and third grade. This is where I believe the main principles of cybersecurity should start happening. As you see, it goes over the same topics as kindergarten and first grade. So let's jump right into it. So as you see, it's basically set up along the same guidelines with society, ethics, accessibility, and career paths. Let's just start off with identifying and analyzing how computing technology has changed the way people live and work. That is, again, a great way. You are finding out what drives computing skills in today's society. If you give them that simple concept of, hey, look how this works, their brain starts working a little bit more and wants to look in depth and start asking questions about this. I strongly think that second and third grade is where you should start getting these comprehensive skills, at least to know how systems work with cybersecurity. And this is a big one that I noticed when I was going through it. Identify and discuss how computers are programmed to make decisions without direct human input for daily life. As we know in most of the media nowadays, a lot of things are moving to artificial intelligence. If we are able to show someone this at a young age and the retainability of that young person, they could be the next person to make the next factory line that only needs one or two humans to actually keep up this factory line, which is directly getting them ready for a workforce. All right, and same thing with this, modeling and simulation, data analytics and visualization. As you see right here, one of the big ones that I've gotten from this is identify and describe data collection tools from everyday life. So going into what might capture your data when you're surfing the internet, for instance. Maybe passwords you're putting in, which I think should definitely be taught to the younger generation. As we know, most of the schools now all work on computers. Most of their classes are done with working hand in hand with different computer functions. Now we're moving into network and system. This set up the same exact way as K through 12, but it gives a little bit more in depth, and you'll see that through the progression of these slides, that every time they go up, it's a little bit more in depth. I like how they're slowly thinking about putting people into these areas. They're giving them building blocks to achieve being somewhat of a mastermind with cybersecurity. Speaking of cybersecurity, it's laid out the same way: risk, safeguard, and response. So, one of my big things on here that I noticed right away is identify why someone might choose to share their account, app access, or devices, which I know in the IT department, nobody should ever, and I can't stress this enough, ever give away their personal information or account information, because no telling what that person might do with it down the line. Maybe they get upset with you, vice versa. It's good to let students know at a young age that they shouldn't be doing things like that. That will get them ready for the workforce later on. Digital literacy, basically going over digital use for grades 2nd through 3rd. Big one I took out of this is conduct basic research based on student identified keywords. So it allows them to basically, what I got out of this is search themselves. Of course, most of the digital age, if you are under the age of 18, you wouldn't have much on the internet about you currently, but it should give them those tools to be able to see if their information is out there on the internet. And we will get into those defining factors in the next one. So next one is grades 4 through 6. So now we're starting to get into middle school. And middle school is where I think a lot more retainability is with students. So they'll be able to retain and apply once they do get into the workforce. And again, it's just the building blocks stacking up to make them a good very cybersecurity savvy. So basically same layout. One of the big ones that caught my eye in this is explain how laws impact the use of computing technology and digital information. One of the main things that I didn't know about when I first started getting into the cybersecurity programs is the laws based behind them, what you can and can't do while you're on the internet. I guess that's one of the reasons why I started ethical hacking at a young age through Can I Hack This Box? That is something that needs to be brought up more often with students trying to go into cybersecurity. Again, I'm not going to hit on all these details. I just want to have them on the screen so you can read them and maybe even refer back to this at a later date. The download will be available for anybody that needs it after this. So networking systems, as you guys heard in my introduction, I am a big network guy, and one of the main reasons why I'm focusing in so much on 4th grade through 6th grade is because retainability. I believe this is where it should start. They should start identifying practices here. Yes, build little building blocks as you've seen in the previous ones for kindergarten through 3rd grade. Build those little building blocks so they see how computers do help us with our everyday lives. But then getting into this, and as you see right there on NSD.3, determining potential solutions to solve hardware and software problems using common troubleshooting strategies. That is major, especially if they are trying to look for an IT job. Even if they're not looking for a job in IT, most of the common work that you see out there, whether it be a desk job, system analysis job, or any IT job for that matter, they have to have good troubleshooting strategies. That is common in our workplace. Of course, you want somebody to be really good knowing about one application compared to the other, but it's always great to have somebody that's rounded knowledge to be able to present and help with those troubleshooting strategies. Cybersecurity, again, explain the differences. Different types of information might need to be protected. So again, still, as you've seen on the previous slides, they're still hammering away at what data needs to be protected. And of course, that is a necessity in most cybersecurity fronts. And digital literacy. One that stood out for me is conduct and refine advanced multi-criteria digital searches to locate content relevant to varied learning goals. That is needed. I mean, they need to show people how to find what they're looking for by using certain keywords, or just giving them tools or websites that they can go and actually research the answers from. I don't see that enough in most of my education through high school. More or less, they would give you reading documents, but nothing that pertains to an actual workplace environment. So I'm happy that they're touching on these at such an early age again. And as you know, as I said prior, fourth grade through sixth grade, the retainability is a lot more there than it would be with anything younger than this. So now we're going to move on through grades through seventh. Now you're getting in the top part of middle school, and they should have these building blocks already previously. Same setup, but one of the big ones that jumped out for me is identify and discuss issues of ethics surrounding computers, computing technologies, and current events. Now this might get a little strange because this could go a little bit more into politics and how things are perceived. I think direct practices would be the best way to go. Just simple ethics classes. Of course, 7th and 8th grade is where you start, I guess you would say, going through a bullying phases where children seem to be bullied a little bit more, and showing them simple ethics will hopefully make some of the kids stand up for people that's being cyber bullied or bullied in the everyday classrooms. And knowing how to do this with computer technologies is key factors that should be learned, I would say, before you get to grade 7 or 8, maybe in grade 4 and 6, but I didn't really see it on those practices. Yes, they gave building blocks for those, but they really didn't give the in-depth look that I was preferably looking for. Now I'm going to briefly skim over all these next ones for 7th through 8th, because we do go all the way up to 12th grade through this, and then at the end I'm going to make some proposals for grades 13 and 14, or better known as associate degree. And one of the big things that stuck out with me is the algorithm and programming, where they actually start making algorithms and different programs within 7th and 8th grade compared to this. I only wish that they were offering this when I went to school. Networking and systems, again, they're getting a little bit more into hardware components and software components, learning how they interact with one another. I would hope by the time somebody gets in 8th grade, the school has it set up where they can build their own computer. Some of the basic necessities needed. That's about the time that I learned how to build and work on computers and troubleshooting hardware issues. As you see right here, one of the bigger ones that popped out with me is the safeguard. Describe physical, digital, and behavioral safeguards that can be employed in different situations. So that, again, going back to protecting yourself and being able to give an emphasis on not letting your information be leaked out there, such as birthdays, days, names, so on and so forth. Here goes digital literacy. Compare the types of tools that choose a search tool for effective and efficiency, and elevate the equal or quality of search tools based on their returned results. Now this, I don't think it was needed as much. The reason why I pointed it out is because that should be something that I believe should be taught in 3rd and 4th grade. It goes back to the building blocks that you need to get up to this standard. I'm sure as when they start rolling this out, they'll redefine it a little bit more, maybe have a teacher teaching the class and then another teacher sitting there and assessing the reactions and engagement within these classes. At least that's what I hope. Next, we have 9th through 12th. Now, this is your high school years. As you see on here, it gives almost the same steps for society, ethics, and the accessibility and career paths. This is where I think they should focus a lot more on career paths. 9th through 12th grade is when you start trying to figure out and identify yourself in this great world. So, I believe they should be able to explore those paths, maybe even set up a program where someone is directly involved with those classes. Maybe get somebody who is currently working in the field to come in and show some applications that they use on an everyday market. Like, for instance, myself, a network administrator, come in and show them how to actually set global policies for Windows, or even setting up a simple LAN network is something that I believe would greatly help these people figure out exactly what they want to do with their life. And then go back to this modeling and simulation. I think this is great. You need more simulated environments to actually show the students what they will be getting into. If I would have knew what I would be getting into at a young age, I would have jumped on it a lot sooner than I have. I am currently 31, and I am just, I would say, a few years ago, just now getting into the IT realm, as some coworkers like to call it. Networks and systems. So one of the main things that popped out for me on this one is explain the levels of interactions existing between the application software, system software, and hardware of a computing system, which that goes back into learning how to set global policies and making sure that your systems actually can interact with each other in a non-error fashion. That highly needed in any workforce nowadays, and will definitely put them at the top of any of their interview processes. So back into this, it's still going personal and organizational information that needs to be protected. I liked that they did building blocks, but I don't think that would be something that needed to be taught again through 9 through 12, just because they've done that before 6th through 8th grade. And then last but not least, digital literacy. As you see, sorry, I scrolled a little bit too far for you on that one. So type proficiently on a keyboard. That is something that I was lacking in school. More recently, I got my words per minute up to 60, which when I first started in IT environment, I was down to like 32 words per minute. And there's a lot of great applications that they could use for doing this online. You have things like Turbo Racer, where they have to draw out a sentence and they actually race on the keyboard or race on the screen, and different games along that line, which makes them a little bit more in depth with typing in the QWERTY standpoint. Identify and select advanced digital tools and resources and create, reverse, and plush complex digital artifacts or collection of artifacts, which is needed. Again, as I stated in the past, they have to have something to sort of bridge that gap between school and actually getting in the market. I mean, one of the main concepts that I learned in school is most of the stuff that I was learning there, unless if I was to get in a specific field for that, I wouldn't be using most of that on an everyday basis in my current career. So, this is some examples for these standards, K through 12. So as you see right here, students could discuss the differences between playing a board game and playing a video game, or mailing a letter and getting a text message, which, phenomenal. Just show them how it works. This is where they could get their acknowledgments and start learning the three-way handshake. Of course, I think that should be mainly taught in 4 through 6, but these again are just some examples of what they could do. I'm hoping that they leave it up to the teacher or professor to give a little bit more hands-on experience with most of these examples. Again, I'm just scrolling through these examples so you can see some examples of topics that we've discussed already. One of the big ones that popped out for me is students should explore the digital divide and see what some of it causes it. Students should also explore what other issues are related to the digital divide. I think that is something amazing to know, just simply so they can try to prevent it or help it out in the future to make it where it's accessible to almost anybody, that wanted to use computers. As we know, in Africa, even though things have been getting better over the years, they still don't have as much access to the digital technology as we do here in America. And things like that do need to be addressed, especially when you're going out into the field. That's something that ethics would play a lot into. If you have a good ethics teacher, then you will try your best to try to help those, maybe even do a missionary over there to show them different computer techniques and how to acquire some of these if they can. Poverty is a discussion for another time. And again, more examples, and then we get into the ethics examples. Maybe should leave it here for a second. Sorry, I was scrolling through because I didn't really see much that stuck out to me in this. It was going over basically stuff that I have already spoke about in previous web pages. And they go through each one of the topics almost per hand. Well thought out process, modeling and simulations, as you see there, data analysis and visualization. Alright, I'm going to stop right there and move on to my next slide. The impacts of computing. As you've seen with our web page, early development with computers is almost a necessity in today's life. Almost any workforce you get into, you're going to be using a computer, whether it's driving a forklift and having to store data that you just moved something from one place to another, or whether it's working as an accountant. You're going to have to input things with Excel. Learning ethics is a major key factor as well, as I've touched on in the past. It's one of the things that you need to learn to have good business practices. When you get into the IT field, you will have a vast information presented in front of you, such as username, passwords, etc. And it's up to you to be a good ethical person to make sure that all that data is secure and never gets leaked out. Then you go into computational thinking, digital literacy, and helping the ever-growing demand for computer experts in the field. As some of you know, the computer field is growing like crazy, especially with the recent pandemic. More companies are moving to online working as much as possible just to keep the spread of the coronavirus down. That is something, if we start training students at a young age to get into computers and know the ins and outs of them, we would be more secure as a nation, not only as a company, but as a nation as well. Having more computer savvy people allows us not to be as worried with cybersecurity as we used to, but still know it's an ever-growing thing in the background. Some of the opportunities associated with the proposed K through 12 cybersecurity standards is learning at a young age, building those building blocks, as I've stated a few times while we were going over the web pages. It's that retainability. You slowly build someone up until they get to ninth through 12th grade. Again, as you've seen, some of the ninth through 12th grade web pages that would go over, I believe they should have learned them previously, but this is the proposal that they are presenting right now. Being able to find what you need with a computer in a test environment. Test environments is a big thing. They do have simulations, but I believe the simulations that I've read go more into the operating system and the kernel, not so much external applications that they would be using for their careers. Showing students career paths. As I said before, my proposal for this is bringing somebody that actually works into the field into the classroom and allowing them to show them what they do on a day-to-day basis with their job. This would give them the ability to get that insight look without actually having to commit to it. And showing students safe ways to use the internet, which, as you've seen, it was discussed in every single grade level, which is amazing, but again, I think they should already know that by the time they get to ninth grade. So some of the weaknesses I found in this proposal was, is it really too early for them to learn? Like, kindergarten and first grade, I wasn't thinking about computers. I was thinking about playing and exploring the world, maybe testing different things. I can honestly tell you there's not much that I remember from kindergarten or first grade. I remember a few key factors, like, for instance, in first grade, we had to feed a caterpillar until it morphed into a butterfly. And that's some of the things that I learned. But I think most key topics in computers won't be retained at that young age value. And that goes into retention value. What age do the mass majority of kids actually have retention value? Like, for me, I believe it's second grade is where I have the most retention. I can remember almost all of my second and third grade years and can almost recite everything that I learned in those grades. Of course, it was multiplication, adding, subtracting, learning the English language, learning grammar, stuff along that lines, which is a necessity for any workforce, of course. But would we be giving them too much information to retain at that young of an age? Which that goes into cost spent in higher learning. What I mean by that is, could we use these resources to help reinforce some of the higher learning or higher grades that could be learning and retaining this information a little bit more than the younger grades? And last but not least, too much information at once. These kids are just getting into school, and we don't want to overwhelm them. So school is already hard enough as it is, and throwing all this extra information at them sometimes cannot be needed. If they go about it in a little bit more of a passive manner, that I think it would go on a little bit better. With, as you've seen with K through first grade, it does seem a little bit passive, but some of those instances seem like they're just trying to feed way too much information to someone that is 5 or 6 years old at the time. So moving on from there, we're going to talk about the threats associated with the proposed cybersecurity standards. So one, they're easy to attack. If you have a 5 or 6 year old inside a classroom, they could click on malware links, worm links. They wouldn't know the difference at that age. Of course, this is one of the reasons why they're proposing it, to show them, but I believe this should be shown more so in third and fourth grade compared to kindergarten and first grade. They could be training the next Kevin Mitnick, which, as you see at the picture right here, was one of the hackers in the early 80s that actually was wanted by U.S. Marshals for hacking into various systems. Next big thing is showing backdoors into simple systems such as Linux kernels that just recently have been hacked, and simple backdoors directly into them. And last but not least, privacy issues. With showing everybody all this information, then it kind of makes it where everybody can look at your personal information, which is not needed and makes it harder for the professionals that are already in the field to protect the information that they currently have. Right here, I have a simple video. I am going to fast forward it to the end because we already are taking way too much time with this presentation. But this is a YouTube video that Malwarebytes has put out on the internet to help train kids in learning about cybersecurity. I'm going to play the first, I would say roughly 30 seconds, and then the last 30 seconds, just so you get a gist of it.
Hello, I am Dr. Evil. The internet is the perfect place for me to unleash my evil schemes. Through the power of the internet, I can target anyone in the world, especially little kids who don't have good security habits. Sometimes I guess their passwords because they are so easy, like 1234 or I like dogs. Sometimes they even tell me. Then I hack into their accounts, I lock them out, and I make everything a picture of me. Other times I sneak into chats or emails to learn details about the kids, like their name, passwords like Orange Dog Fluffy Head. Create these passwords with your parents. Never tell people on the internet your full name, address, phone number, or where you go to school. Report bullying or inappropriate conversations to your parents, and never join a video meeting without an okay from your adult. Always ask an adult before downloading software, and don't click on links or ads that look weird.
Alright, again, that was just a brief video I wanted to show, just to show that the tools are already out there for training kids. Most of these big corporate industries want to make sure to train the children as much as they possibly can early on, especially Malwarebytes and other antivirus protection agencies. They really want to stress that because, as we know, if someone comes into your business that isn't computer savvy, they are a higher risk than somebody that is. One of the main reasons why I believe this is a great thing to show kids at a young age. So moving on, we're going to go into my proposal for K through 12 cybersecurity standards, and this will also lead into the associate's degrees, your freshman year and sophomore year going for your associate's degree in college. So one of my big things about reading over all this information is there needs to be more test environments. Yes, during the proposals they go into test environments and showing the information a little bit more, but I don't feel like they go as in depth. I didn't really get my first test environments until I was a sophomore at Onondaga Community College, and learning how exactly all this stuff works together. Now, if we were able to set up these test environments at, let's say, 6th grade, where I talked about a lot of the retention value being a little bit more so than 1st through 4th grade, I think they'll be able to process the information a lot better when they get up into the higher scopes, such as 9th through 12th grade with these. Another proposal that I would like to make within these test environments is learning a little bit more about the applications. Now we're going to go into grades 13 through 16, which, as you know, is your beginning years in college, learning more about application-based usage. That's something that I have not seen in a majority of my studies. Of course, applications are always evolving, different instances, and it's hard for schools to get a hold of some of these products. But, for instance, things like Unitrends or Bitdefender or Sonic Wall, those are things that need to be shown how to configure when you get to these ages, or to these groups, grade levels. One of the biggest things that I had to overcome as soon as I got into the IT field was, as soon as you sit down in your seat for your first day, you have about 30 to 40 different applications that you will use on an everyday basis that needs to be performed for your job. Simple configuration, troubleshooting of these applications need to be taught in school. That's something that has been missed on multiple levels that I have learned on. Yes, you do get introduced to Netacad and learning how to set up simple Cisco routers and things along that line, but you don't really go into like Splunk and how to tell whether you're being attacked or not according to the graphs on there, which I could get into a little bit of Splunk after this recording is over. But those are my two major proposals. More test environments, getting kids to learn about applications, and basically showing them concepts of how to reconfigure these applications to make it where they can use them on an everyday basis. So, with that being said, in conclusion, I feel as if cybersecurity should be taught to grades 2 through 12, more so than kindergarten and first, because retention ability. I think some of the strengths of this program is allowing kids to see it at a young age so they know the threats and also the fun things that can be done with the internet and networking and cybersecurity. One of the big weaknesses is the retention value, and is it too early to teach kids? They might be overwhelmed by all the information that they're trying to get at that young of an age. Last but not least, my proposal for K through 12 is more test environments, being able to connect simple networks, maybe even make simple batch files to learn how packets move throughout networks. And then my proposal for grades 13 through 16 is learning applications a little bit more and how to configure these applications such as Splunk and Malwarebytes, just so it makes it easier for that third party to capture some deadly virus that might be infiltrating your system. So, last but not least, all this information was taken from this website right here. And as you've seen, most of the slides that we went over in the background, web pages that we went over in the background, were taken from that source as well. I hope you enjoyed the presentation, and if you have any questions, please email me. And I will also be taking questions from the classroom right now. Thank you so much for your time, and you have a great day.